When most people imagine the solar system, they picture planets orbiting the sun in empty darkness. But the space around us is not simply empty, and the sun's influence does not stop at Neptune or Pluto. Far beyond the planets, the sun creates a vast invisible region called the heliosphere. It is often described as a bubble, but it is not made of glass, gas, or any solid surface. It is a moving region of plasma and magnetic fields, inflated by the sun itself. Inside this bubble, the space environment is shaped mainly by solar material. Outside it, the particles and magnetic fields of the wider Milky Way begin to dominate. The heliosphere is therefore one of the solar system's most important boundaries, even though we cannot see it with our eyes. The force that creates the heliosphere is the solar wind. The sun constantly releases charged particles from its outer atmosphere, mostly protons and electrons. These particles stream outward in every direction at enormous speeds, carrying part of the sun's magnetic field with them. This flow passes Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and continues far beyond the familiar planetary region. The solar wind is extremely thin compared with air on Earth, but over astronomical distances it becomes powerful enough to shape an entire zone of space. In simple terms, the heliosphere exists because the sun is always blowing material outward. That outward pressure pushes against the surrounding galactic environment and carves out a cavity around our star. To understand why the heliosphere has a boundary, we need to look beyond the solar system. The space between stars is called the interstellar medium. It contains thin gas, dust, charged particles, and magnetic fields spread throughout the galaxy. It is far emptier than anything we experience on Earth, but it is not nothing. As the sun travels through the Milky Way, its solar wind meets this surrounding material. The result is a pressure balance, solar plasma pushing outward from the sun, and interstellar plasma pressing inward from the galaxy. The heliosphere is the cavity produced by that interaction. It marks the region where the sun's particles and magnetic influence still dominate over the background environment of interstellar space. The heliosphere is sometimes compared to a comet because it may have a rounded front and a stretched-out trailing region. This shape happens because the sun is moving through the galaxy rather than sitting still. On the side facing the sun's direction of travel, the heliosphere can be compressed by the oncoming interstellar medium. On the opposite side, solar material can be drawn into a long wake known as the heliotail. Scientists still study the exact shape, because magnetic fields, solar cycles, and interstellar conditions all complicate the picture. But the key idea is clear: the heliosphere is not a neat, fixed sphere. It is a dynamic structure, constantly sculpted by motion, pressure, and magnetic forces. One of the heliosphere's most important functions is shielding. The galaxy is filled with high-energy charged particles known as cosmic rays. Many of these particles come from violent astrophysical events, such as exploding stars or other energetic processes in space. If too many of them reach the inner solar system, they could pose risks to astronauts, spacecraft electronics, and planetary atmospheres over long periods of time. The heliosphere does not block all radiation. Uncharged gamma rays, for example, are not stopped in the same way. But the solar wind and the interplanetary magnetic field deflect or reduce many charged particles coming from outside the solar system. It is not a perfect shield, but it is a meaningful layer of protection. As the solar wind travels outward, it eventually reaches a point where it can no longer move freely at its original speed. This region is called the termination shock. The name does not mean the solar wind disappears. Instead, it means the flow slows down abruptly as it begins to feel the pressure of the interstellar medium. Before this point, the solar wind is moving faster than certain waves can travel through the plasma. At the termination shock, it becomes slower, hotter, denser, and more turbulent. A spacecraft crossing this region would not hit a wall, but its instruments would detect a major change in particle behavior. The termination shock is the first clear sign that the sun's outward flow is losing its dominance. Beyond the termination shock is the heliosheath, a broad transition zone near the outer edge of the heliosphere. This region is not calm or simple. The solar wind has slowed, but it has not fully given way to interstellar space. Particles are compressed, magnetic fields become more irregular, and the flow becomes turbulent. A useful comparison is the disturbed water where a fast river current meets slower water near a boundary. The heliosheath shows that the edge of the sun's domain is gradual rather than sudden. It is not a clean line drawn in space. It is a thick, complicated region where solar and interstellar conditions interact before the final boundary is reached. The outer boundary of the heliosphere is called the heliopause. This is where the pressure of the solar wind is finally balanced by the pressure of the interstellar medium. Inside the heliopause, most of the plasma environment is still tied to the sun. Outside it, spacecraft enter a region dominated by particles from the wider galaxy. This is why the heliopause is often treated as the beginning of interstellar space. But it is important to be precise. Crossing the heliopause does not mean escaping the sun's gravity. The sun's gravitational influence extends much farther, toward distant icy objects and the Oort cloud. The heliopause is a plasma boundary, not the final gravitational edge of the solar system. The first direct explorers of this distant boundary were the Voyager spacecraft. Voyager 1 and Voyager 2 launched in 1977, originally to study the outer planets. After their planetary flybys, they kept traveling outward, becoming humanity's most distant operating spacecraft. Voyager 1 crossed the heliopause on August 25, 2012. Scientists recognized the crossing partly because the spacecraft measured a sharp increase in plasma density, showing that it had entered a region filled with interstellar material. Voyager 2 crossed the heliopause on November 5, 2018, following a different path and providing a second set of measurements. These crossings transformed the heliosphere from a theoretical boundary into a place that human-built instruments had actually sampled. The Voyager data revealed that the edge of the heliosphere is real, measurable, and more complex than expected. Scientists saw changes in cosmic ray levels, charged particles, magnetic field behavior, and plasma conditions. Some results matched predictions, while others raised new questions. For example, the transition into interstellar space did not always produce the simple magnetic field changes that older models might have suggested. This matters because the heliosphere is a natural laboratory for plasma physics. It shows how a star interacts with the material around it. Since other stars also produce winds, they may create their own versions of heliospheres, called astrospheres. By studying our own, we learn how stars shape the environments around their planetary systems. The study of the heliosphere belongs to a broader field called heliophysics. Heliophysics connects the sun, the solar wind, planetary magnetic fields, cosmic radiation, and space weather into one system. This is not just distant astronomy. Solar activity can affect satellites, radio signals, navigation systems, power grids, and the safety of astronauts. The heliosphere also changes over time. During periods of stronger solar activity, the sun's magnetic influence can reduce the number of galactic cosmic rays entering the inner solar system. During weaker solar periods, more of those particles may get through. So the heliosphere is not a static bubble. It expands, contracts, and shifts with the behavior of the sun. The heliosphere changes our sense of where we live. Earth is not merely a planet orbiting a star in open space. It is inside a vast solar-made bubble moving through the galaxy. This bubble is inflated by the solar wind, shaped by interstellar pressure, stretched by the sun's motion, and threaded with magnetic fields. It helps protect the inner solar system from some charged cosmic radiation, while also defining a major boundary between the sun and the Milky Way. The Voyager spacecraft have crossed that boundary, but only along two narrow paths through an enormous structure. Much remains unknown. The heliosphere is invisible, distant, and constantly changing, yet it is one of the most important architectures surrounding our cosmic home. If you found this helpful, please like this video and subscribe for more explainers.